Hello, my excellent AP biologists. I am re-recording a few practice problems for you for population ecology. These are the ones that are linked in your group shared notes. So this first practice problem, as you read number 1 to yourself, what I would do to approach this would be to identify what you know. So the first thing here is it's a population of 265 swans. So hopefully you're thinking N equals 265. The population's per capita birth rate is 0.31. So when they say per capita, that means per 1,000. All right, so it wasn't that 0.341 of a duck was born, a third of a duck, right? What this means is that the B equals 0.341. And same thing, per capita death rate is 0.296, so death is 0.296. So just looking at that right off the bat, if you see birth rate is greater than death rate, then probably this population is going to increase, right? Because that's going to be a positive number. So what are they asking for? What is the per capita growth rate, R, for this population? So you know R is going to be equal to the birth rate per capita minus the death rate. So all you have to do is say R equals 0.341 minus 0.296. And then you're going to do your math on that. I need a calculator. It's something like 0.045. Okay, big number taking away a small number. This is a positive number. So is the population increasing or decreasing? Hopefully you would see that this population is going to increase. And then it asks you how many swans will be added in a year. So that is the change in the population over time of 1 year. So how much is it going to change over a year? Well, that is equal to R times the current population, the per capita growth rate times the current population. So then you're just going to take 0.045 times, how many swans do we have? N, 265. So do your math on that. And I think it's going to come out to a whole number of 12. Okay, so that is problem number 1. Problem number 2, there are 190 gray tree frogs in a swamp. So already you should be thinking to yourself, all right, N equals 190. If R is 0.093, but notice there's a negative. So right away in your mind you should be thinking, uh-oh, number of frogs is going to go down, okay? Because it's a negative number. Predict the population size next year. So this is your change in your population over your T in this case will be 1 year, is going to be R times N. So then we just plug in our numbers. It's negative 0.093 times 190. And then do your math on that. I think it's equals minus 17.67. So we'll just say approximately minus 18 frogs. So that's how much the population is going to change over time. It's going to be decreasing by 18 frogs. So how many frogs do we have now? Well, currently 190. So following 1 year, right? This would be, you know, N now, and then N and time plus 1 year is going to be 190 minus 18. So then you're going to be down to 172 tree frogs. That would be your answer. Okay, so I needed to scroll up there a little bit. So now let's look at our next question. A population of 1,492 Baltimore Orioles. So right away I'd write N equals 1,492. Is introduced into an area of the Nerstrand Woods. Over the next year, the Orioles show a per capita death rate of 0.395. So I know D is equal to 0.395. And while the population drops to 1,134. So this is the population the second year. So it went from 1492 and it went down, how many did it lose if it went down to 1,134 after that second year? So that population changed by 358, right? That's the difference between that. So my change in population, okay, my change in N over that change in T over time of 1 year was minus 358. Okay, so hopefully you see that's how much the population changed from, let's say, year 1 to year 2, was a difference of 358. So now what it's asking is, what's the birth rate for this population? So you know that delta N times delta T is going to equal, right, R times N. So now we know minus 358 is going to equal to R times N. Well, what do we know? We know that the population N was 1,492, right? So minus 358 equals R times 1492. So now what you can do is you can divide, if you want to, by 1,492. Oops, sorry, dyslexia there. Divide by 1,492 on both sides, and then this will give you R. So 358 divided by 1,492. Okay, so just when you do the math there, sorry it's so messy. So if you do 358 divided by 1,492, you get something like 0.3 or 0.239. So let's say 0.24. And remember, it's minus 0.24 because you still have the population went down by minus 358. So minus 0.24 equals R. Well, what do we know R is equal to? R is equal to the birth rate minus the death rate. So minus 0.24 equals, we don't know the birth rate, so let's put B. We do know the death rate. The death rate was 0.395. So now just add 0.395 to both sides. So plus 0.395, sorry, plus 0.395, then you're going to get your birth is going to be equal to 0.155. Sorry, that was so discombobulated. Okay, hopefully you got that. I'm going to need to erase this. Scroll up here a little bit more. All right. So 780 turkeys live in the Merriam Township, which is 92 acres in size. Let's look at the first question is, what is the population density, turkeys per acre? So all you have to say is, well, I have 780 turkeys, right, per 92 acres. Okay, so what is 780 divided by 92? That looks like 8.48 turkeys per acre. Okay, that would be your density. What is the growth rate for this population? Okay, so now you're trying to figure out your change in the population over time. So you're solving for first R, and R equals B minus D. So let's see what we have of that. The per capita birth rate is 0.472, and the per capita death rate is 0.331. So R equals 0.472 minus 0.331. So R is equal, if you do the math, to 0.141. Right? And then multiply that by how many, remember what we said, so the change in population over the change in time is R times N. So now you have your R is 0.141 times how many turkeys do we have? 780 turkeys. So if you do the math on that, I think it's somewhere around 110 turkeys a year. All right, so what will be the population size after 1 year? Well, our change in population is 110 turkeys. How many turkeys did we have? We did have 780. So then you're just going to add those up. Then I would assume that we're going to have somewhere around 890 turkeys. All right, let me pause and do some erasing. Okay, so here is your last problem. One dandelion plant can produce many seeds, leading to a high growth rate for dandelion populations. If a population of dandelions is currently 40 individuals, so N equals 40, and R max, R equals 2 dandelions per month, predict the population at the end of 1 month. Okay, so the change in the population over time is going to be R times N. So now we're just going to say R is 2 and N is 40. So 2 times 40 is 80. Okay, so after 1 month though, what we're going to do is that's equal to the change in population over time is 80. Well, that's the change. How many dandelions did we have to start out with? We had 40 to start out with. So 80 plus 40 is going to equal 120 dandelions. So now, let's say it says, imagine the dandelions mentioned in number 5 cannot grow exponentially due to lack of space. The carrying capacity for their lawn is 140 dandelions. So K is going to equal 140. After 1 month, how many additional dandelions can the lawn accommodate? So that's kind of a mix. I don't really especially like the way that particular question is worded, but let's work through it. So let's redo the problem. So N was 40, R is still 2.0, but now we have a new number. We have K, and K is equal to 140. So now we're looking at a different equation. Now our change in the population over time is going to be R, our intrinsic rate, right, of increase, times our current population, and then how close are we currently to our carrying capacity. So now we need to look, okay, we still have, let's do this right here. Our carrying capacity is 140, right? What's our current population is at 40. And we're going to divide this by K, okay, times N, which is our current population, times our intrinsic rate of increase, which is 2. So do your math on that. And I'll do some math as well. I think it is 57. I don't know what just happened there, and I apologize, but delete that out. Okay, so I think when you do the math there, it is going to be 57. Sorry, I must hit something. And then you need to add that to your current population. Your current population is 40. So your new population is going to be 97. Okay, if we add that in. And I hope that is, oh, and our change, we kind of already handled number 5, right? We did our change in our population was 57. And then we added it in. So if we said after 1 month, if you really wanted to know what that is, you could say, well, it will hold. I'm going back to this one. I just think this question's a little bit confusing, but after 1 month of growth, if we are impacted by our carrying capacity, you could say 140 is our carrying capacity by how many dandelions we would have at the end of 1 month. So it could then still take another 43 dandelions. I guess that's how you could answer that particular question. All right, hope that's helpful.